Hello everyone, my name is Ken, and the purpose of this video is to remind myself about the items and inventory system that I just finished creating. So, let's get into it. I'm actually going to play this in a two-player multiplayer setup because this system is working in multiplayer. So, if I actually, before we walk over there, I'll just open my inventory and you can see that there is some equipment slots, then a vicinity widget. And if I walk over to these items, they show up in the vicinity widget. And if I back up, you see they go away. That's pretty cool. I can equip items. And if I equip an item that's marked as a container, we can actually get another widget here to see the contents of that item. I can store items in items, and I can re-equip them, or I can just drop them back off into the world, or I can store an item, drop it into the world, and another player can come over here and you can see they're able to now see the contents of that item. And them too can drop items. Yeah. So that's the fundamentals of the whole system working. I think next I'll show you the design pattern I used in order to control the flow of that data and the widgets and stuff. So I'm using the MVC design principle. It's pretty common in Unreal from what I read. The way it works is that you have three layers. You have a model layer, which for us is the data layer. There's a view layer, which would be like the widgets. And then there's the controller layer, which would be widget controllers. So the model or the data models, they're responsible for handling all the actions by the user, whether they want to equip items, drop them. Its job is to run server calls, server RPCs, client RPCs, and track all that data. And then when that data is completed and all of its actions are done, it will broadcast the new data out to the world. And the controller is responsible for subscribing to those broadcasts and those events. The controller can also run functions directly on components and the data layer. So equipment component is one example. Vicinity component is another example. Um, that's the model side. Now the widget controller layer is, like I said, responsible for listening to the data being changed, and then it will capture that data. It has an opportunity to mutate that data, and then it will broadcast its mutation up to the widgets. Well, not up. The widgets actually have to subscribe to the widget controller. So that's where the view layer comes in. Widgets have no concept of equipment components. They never run functions on equipment components, vicinity components, any of the data stuff. They're only asking the widget controller for data. So uh, that's kind of how we separate the back end data from the like front end UI stuff. All right, let's get into some code. Let's close this out. I have this broken up into two parts. There's the back end and front end. So the back end is here in the items root layer or directory, and then the front end is in the UI item directory. We'll go over some of that in a little bit. For now, let's talk about the backend layer. Before we do that, I should show the data asset that we have here. So this is a data table that stores all possible items in the game. Right now we only have two, an apple and a backpack. And then there are item definitions attached to each item in the game. This is where all that static data lives. This is also where we define whether or not an item is considered a container. and what the size of that container is. So if I change this to 16, save it, do play, and then equip this, you'll see, whoop, did that not save? Nope. Let's try this again. There we go. So you can see now I have 8 slots instead of 16, and everything works as you would expect. So these item definitions, this is an object that is defined in C++ here. It's a strut. So all the information that you see here in the screen is defined here. Um, one cool thing about this is they're considered instance structs. So that means in Unreal, when you use an instant struct, they can you can override them. They're polymorphic, and you can have things like, instead of just item definition, you can have weapon definition or some other definition, food definition or edible definition, consumable definition. And that kind of allows you to just have a lot of abstraction and control the scale at which you can create these items. Next is the concept of an item instance. So items, when you see an item in the world, there's always going to be an item instance associated with it. The item instance actually represents the real item that we're tracking in the backend. When you look at, for example, whoops, these 2 items here, these are considered item actors. So it's just a physical manifestation of the item instance, but these can be destroyed. The actors themselves can be destroyed, and the item instance lives on. So it's the backend's job to track the item instance regardless of where or how it's shaped in the world. It can be an UI component, it can be an actor, it can be other things. So this is basically the source of truth of an item. And since it's an instance, you can have, let's say, 2 apples, which means there would be 2 item instances, one for each apple. Um, yeah, so like I said, item actor is the actor itself in the world. It's the physical representation of the item. And then we also have a subsystem, which is the entry point. So when you load the game for the first time, it will initialize. And it actually pulls all that data from that data table that I showed a second ago. And it will load that data into the item registry. This is also kind of the central API that the backend system uses to register items, unregister the items, and do other things like find items and stuff like that. Let's do front end. Front end's a little trickier. It's actually way more complex because there's a lot of dragging and dropping and things like that. So, in order to make this easier, since there's multiple types of widgets like vicinities and containers and equipment slots and things like that, the front end layer has all of these parent classes that our widgets inherit from. So anytime, for example, if I equip an item, this box here is a slot, obviously. And then there's the item itself. Again, slot. And then the item. We can actually see that here. There's the item slot. This is the parent class. And then there's an item widget, the item itself. And if we go into our actual widgets, there's a inventory widget. So if I hit play again, this whole box here is the inventory widget. It also all of widgets in the game are required to use this as their base class. This is how we tell every widget the concept of a widget controller. So anytime you create a new widget, it has to take on this class as its parent, and it has to set its widget controller. Now, in the inventory widget itself, you can see we have containers, equipment, and vicinity. And then the inventory widget itself, which I showed you. Actually, I'll keep this open. Let's do this. Let's turn that off. So this is the inventory widget, which is here. And you can see that it's properly inheriting from our no remains user widget header. And then it's setting its own controller, which is actually here, the inventory controller. The inventory controller also has a parent, so all controllers have to take on a widget controller class as well. I guess the easiest way to demonstrate this would be equipment. So equipment slot, you can see, is taken on the parent of a draggable item slot. And then the equipment item is taken on the parent of draggable item widget. And the nice thing about this is that all you have to do is override a few of the parent functions in order to get things working, because all of the complex data lives in the parent class. So a lot of that information is happening here. So that way, these child classes, they just have to do a few things. So they set their widget controller, they set up the drag drop handler, then they can go on to just doing visual stuff. I think that is pretty much it. I'll show the equipment component real fast because that's kind of the heart of it all as far as like saving information. So the equipment component is what, actually, you know what? Before we do that, we should look at the controller. So the widget controller, which is here, you can see this is where all of the uh, binds happen to listen for events that are happening from, like this one here is listening for equipment changes on the equipment component. And if it receives an event, it will handle that by, again, given an opportunity to mutate and then broadcast its own delegate up to the widgets. And then the widgets are listening for this one. So the widgets have no idea that this exists. They only know that this class exists and that these delegates exist. And then the equipment component, right? So that is here. And so this is where like the server will do all the saving and tracking and stuff like that. One thing to take note of is the where is it? It's going to be this, not this, I'm sorry. The item subsystem. So it's important to note that since this is multiplayer, there's going to be a server version of this, which is where all the real like data lives. So the server is responsible for making sure that no one's cheating and that these items actually are legit. And players as clients also have their own item subsystem. So we have to keep like a shadow copy of all items. And so the equipment component or any other component that's going to be interacting with items has to have that concept of I need to register this with the server and then I can give it to the client as its shadow copy. The best way to kind of demonstrate that is when you equip an item, We make sure that we're the server. Since we are the server, we're going to ask the item subsystem to get the instance, and then it's going to pass that information by reference to this variable. And then what we do as the server, we're going to create an array of items that we're going to register. This is going to be used to give it to the client. So the server keeps track of the owned item instance, and then it creates the new entry, it updates equipment slots, marks them as dirty so that way they replicate. And then at the very end, if there's a container, it's going to do the same thing. It's going to add items to the container. And then at the end, it will register all these items to the client. So this is the server making this call to the client. And the client will, so this call gets executed as the client, which is going to have its own item subsystem that it will register its shadow copy. And so that concept is important to not forget about, because you could register an item to the server, forget to give it to the client, and then when they try to drag something, it just doesn't work. The server knows it's there, but the client doesn't see the changes on their end. Yeah, I think that's the heart of it all. Yeah, hope you enjoy.